Hello, my name is Lisa. In this section, we're going to talk about fractions. The top part of a fraction is called the numerator, and the bottom part is called the denominator. The line that separates numerator and denominator represents the operation of division. So 1/2, 1 is your numerator. The line here means we're dividing by 2, which is the denominator. A counting number is called prime if it has exactly 2 factors, just 1 in itself. So 3 is a prime number. The only 2 whole numbers I can multiply together to get 3 are 1 and 3. A counting number greater than 1 that is not prime is called composite. For example, 50 is a composite number. 50 can be written as 1 times 50 or 2 times 25. And there are other ways of doing it as well, but all you have to do is prove that there is at least one other way where you can multiply 2 whole numbers to get the number you're looking at. And the number 1 is a special number. It is neither prime nor composite. So when we're talking about prime and composite numbers, we're talking about numbers greater than 1. I'd like you to pause the video at this point and write down all the prime numbers between 1 and 20, and then resume playing after you've written those prime numbers down. You should have prime numbers between 1 and 20 are 2, 3, 5, 7, 11, 13, 17, and 19. If you want to determine whether a number is prime or composite, you need to see if there are any numbers other than 1 in itself that will divide evenly into that number, or that will multiply together to give you that number. 2, the only 2 factors of 2 are 1 and 2. 1 times 2, the only whole numbers I can multiply together to give me 2. 28. If you think all even numbers, 2, 4, 6, 8, 10, 12, etc., all even numbers have a factor of 2. So I know 28 is even. 28 can be written as 1 times 28 or 2 times, and in this case I know it's 14. If you're not sure, you can divide on the calculator. And if I use my calculator over here to the right, 28 divided by 2 is 14. So I know that 28 is composite. And 2 was prime. Is 31 prime or composite? Now 31 is going to take a little bit more work to do because we're going to have to do some division here. 31. Well, I know it's not even, so it's not divisible by 2. I need to see, is it divisible by 3? If you want to check for 3's, you add the digits and see, is that number divisible by 3? So in this case, 31, if I add 3 plus 1, I get 4. 4 is not divisible by 3, so 31 is not divisible by 3. 5, you want to see it's divisible by 5 if it ends in 0 or 5. So I know 31 is not divisible by 5. Now I can check by other numbers, is it divisible by 7? 31 divided by 7 is 4.4. So I know it's not divisible by 7. And I know I can stop there since 4 is less than the number I was dividing by. 4 is less than 7. I know I've checked all the possible combinations. Whoops, not composite. I'm circling the wrong one. 31 then is prime. And if we want to check if 100 is prime or composite, well again, 100, it ends in 0. If the last digit to the right is 0, I know it's divisible by 5. 100 equals, and if you divide that out on the calculator, 100 divided by 5 is 20. So it's 5 times 20. So 100 is composite. If you want to write a number in prime factored form, it means we're going to form the product of all prime factors of a number so that when multiplied, the product gives us the number we were looking for. One way of doing this is by writing a factor tree. So I'm going to show you how to do that with the number 60. 60. Okay, so when I look at 60, I know 6 plus 0 equals 6, and 6 divided by 3 is 2. I know 60 has a factor of 3. If I add the digits and that sum is divisible by 3, my number is divisible by 3. 3 times 20 is 60. When I'm doing a factor tree, I circle the prime numbers. So my branches, 60 branches off into 2 factors, and I circle the prime ones. 20 ends in 0, so I know it has a factor of 5. 5 times 4 is 20. 5 is prime, so I'm going to circle it. And I still have a branch that doesn't have any leaves on it or any prime numbers on it. I'm going to say 4 can be written as 2 times 2, and 2 is prime. Now if you notice, all of my branches have leaves or circles at the end. I know I've written all of the prime numbers that I can. I've broken it down as far as it will go. And then you can start writing your factors. 60 is 3 times 5 times 2 times 2. We don't have to write them in order, but sometimes it's nice to. And you can always check by multiplying out 3 times 5 times 2 times 2. I get 60. So that is written in prime factored form. The next number we're going to look at is 393. And again, I see all those 3's there. If I add 3 plus 9 plus 3, I get 15. 15 divided by 3 is 5. That's my rule for divisibility by 3. I know 393 has a factor of 3. I'm going to bring my calculator back up. 393 divided by 3 is 131. So I'm going to circle 3. And then I have to try and see, is 131 prime or composite? Well, 131. I know it's not divisible by 2 because it's not even. 1 plus 3 plus 1, 5 is not divisible by 3. It's not divisible by 5 because it does not end in a 0 or a 5. So I can see, is it divisible by 7? No. Is 131 divisible by 11? No. 131 divisible by 13? No. And now if you notice, when I divide it by 13, I get 10 point something. 10 is less than 13. I know I can stop here. 131 is prime. So 393 is the product of 3 and 131. There's my prime factored form. Properties of 1. Any non-zero number divided by itself is equal to 1. For example, 5, if I divide by itself, I divide by 5. 5 divided by 5 is 1. Negative 2 divided by negative 2 is also equal to 1. Any number multiplied, and this works with division as well, multiplied or divided by 1 remains the same. 7 divided by 1 is still 7. 3 times 1 is still 3. Negative 1/2 times 1 is still negative 1/2. We're going to use the properties of 1 to write fractions in lowest terms or reduced form. First, write the numerator and denominator of the fraction in prime factored form. 2. Use the property of 1 to replace each pair of factors common to both the numerator and denominator with 1. And 3. Multiply the remaining factors in the numerator to get the new numerator and repeat in the denominator. So we're going to do some examples here. So step 1 said to write in prime factored form, 15 is 3 times 5. And same with my denominator, 25 is 5 times 5. Then we're going to replace all the factors that they have in common with 1. So what this means is I have to look for one common factor to the numerator and denominator. 5 over 5, that's the same as saying 1. So I look at what remains in the numerator, in this case just a 3, and in the denominator 5. 15 over 25 is the same as 3/5. We'll do the same with 49 and 56. 49 is 7 times 7. 56 is 7 times 8. I look for those pairs that are common, one factor in the numerator with one factor in the denominator, and I replace with 1. What I'm left with in this example is 7 divided by 8. And our last example here, 84 divided by 100. Well, I know 84 is even, so it's going to be 2 times 42. 42 is even, so I know I can break 42 down as 2 times 21, and 21, I'm going to keep the 2 times 2, 21 is 3 times 7. So there's my prime factorization for 42. 100 is 4 times 25, and 4 is 2 times 2, and 25 I can rewrite as 5 times 5. Now I look, I have 2 over 2, 2 over 2. They don't necessarily have to line up over each other as long as there's 1 in the numerator and 1 in the denominator. And then what I have left, 3 times 7 is 21 over 5 times 5 is 25. And there's my reduced form of 84 over 100. When you multiply two fractions, you want to go and multiply the numerators together, multiply the denominators together. In other words, go straight across. And we always want to reduce our fractions. In example number 1, I'm going to multiply my numerators. 1 times 14 is 14. 10 times 11 is 110. And then I need to reduce. 14 is 2 times 7. 110 is 2 times 55. I can cancel out those common factors of 2. 7 is prime, and it does not have anything in common with 55. So I know I've got my fraction in lowest terms. Now in the next example, I'm going to show you a little shortcut way. You don't have to multiply your numbers all out together. You can kind of look at what factors they have first. It makes it a little bit easier to reduce. 15 can be written as 5 times 3. And if you notice, we have a factor of 5 in the denominator, so that works out nicely for us. I'm going to look 24. There are lots of ways I can factor 24. But I see I have an 8 in the denominator, and I know 24 is 3 times 8. In the denominator, I have 8 times 5. Now, I did not take these all the way down to prime factors because I noticed they did have a common factor. We have an 8 in the numerator and an 8 in the denominator, a 5 in the numerator and a 5 in the denominator. And what we're left with, you can always think you have a factor of 1. If everything else cancels out, you have a factor of 1. 3 times 3 is 9 over 1, which I can reduce to the integer 9. So if you can reduce your fractions down to an integer, you want to do so. Always writing them in the simplest terms possible. We're going to do the same thing in example 3. 5 is prime. 12 I can break down, and this time I look in the denominator, I have a 6, and I know 12 is 6 times 2. 6 in the denominator, and 25 I know has a factor of 5. In fact, 25 is 5 times 5. Remember, you have to cancel 1 for 1. 1 5 in the numerator with 1 5 in the denominator. 1 6 in the numerator with 1 6 in the denominator, and what we're left with is 2/5. And the last thing we're going to do in this video is divide two fractions. To divide two fractions, multiply the first fraction by the reciprocal of the second fraction. The reciprocal of the fraction is the fraction flipped upside down. You can reduce the fraction. If you can reduce the fraction, you should always do so. So We're going to keep the first fraction the same, but we change from division to multiplication, and we take the reciprocal of 1 over 16 is 16 over 1. Now I have a multiplication problem. 3 times 16, and again, I'm looking at my denominator. 16 is 8 times 2, and in my denominator I have 8 times 1, so I know I can cancel the common factor of 8. 3 times 2 is 6 over 1, or just plain 6 for my answer. Example number 2 says we have 7/10 divided by 7. Remember, 7 divided by 1 is the same as 7. So this makes it a little bit easier to rewrite that. 7 over 10, change division to multiplication, and take the reciprocal of 7 over 1 is 1 over 7. And here I notice right away I have 7 in the numerator and 7 in the denominator. I can cancel those out, and I wind up with 1 over 10. 1/10 is my final answer. Now when you're typing your answers into MyLabs Plus, if the original problems contain fractions, your answer should be written in fraction form. Only write the answer as a decimal if the original problem had decimals in it. Our last example here, first fraction multiplied by the reciprocal of the second fraction. And here I'm going to break these down. Numerator, we have 5 times 9, which is 3 times 3. And we have 3 times 10, which is 5 times 2. Common factors, we can cancel 1 3 in the numerator with 1 3 in the denominator. 5 and 5. And we're left with 3/2 as our final answer. And this concludes the video on fractions. Have a great day, everybody.